Hi everyone, and welcome to this Excel tutorial video. For this video, we're just going to stick with two random variables, x and y, and their randomly generated errors. So keep in mind we're doing this generally, not only because it'll apply to both activities, but this is just good general practice for when you encounter this kind of situation again. But for our lab, remember that time is going to be x, and your height or your length is going to be y depending on the activity. So the first thing I'll go over is standard deviation. So all we need to do to get standard deviation, this is just std, is equals stdev right here. This is Excel standard deviation function. And just click and drag everything you want to get the standard deviation of, and then push enter. And there you go. That's the standard deviation of x. So this gives us an idea of how far the data is spread apart. So it's spread about by about 2, and 2, whenever you're talking about data itself, don't forget the units, so this could be 2 elephants, marbles, gumballs, what have you, but this is just a general example. So that's how you quickly calculate the standard deviation. For the average, remember, it's going to be the same idea, but the function you're going to use is just average. All right. And then, as I mentioned, these were randomly generated errors, but we're at the point where you've already gone through, you've calculated the averages of everything, and you've gotten their absolute errors. So for each of the lengths or heights. So to go over how to do absolute error in Excel, you're just going to hit an equal sign and then open a parenthesis, and you're just going to use the max and min functions. So we have max, we open another parenthesis, and then fill this all in, and then close the parenthesis. And what this does is it picks out the maximum value of this column here. So similarly, we're going to use min, select the exact same data, and then that's actually going to find the minimum of this set. So it's going to pick out the smallest number here. And then we do double parentheses because we have to close both the function and the difference, the subtraction. We're using parentheses because of order of operations. We want to subtract before we divide. And then all we have to do is divide by 2. And just like that. So as you can see, these come out to wildly different answers. But again, this is all randomly generated. This is just an exercise just to see the mechanics of what you have to do when you actually process your data for the lab. So now that we have all of that out of the way, let's talk about why we take the logarithms and which logarithm to use. So if you remember from log rules, the log of something to the nth power is the same as n times log of that something. So the reason we're taking the log of both variables is so that when we get a regression line, we find its slope, and that slope is the power relation between the two variables. So we know what y equals x to the n is. N is that slope that we're going to find when we do the regression, which we're going to do, but let's first go ahead and take the logarithms. So in this column, which is just log of x, we do equal sign log 10. Log 10 is just a good default logarithm to take. There are many kinds of logarithms. Two of the most other popular ones are log base 2, which is binary, so 0 or 1. If you're in computer science or any of those other applications, you deal with that log base all the time. And then in math and physics particularly, we generally do the natural logarithm, which is just the inverse of the natural number e. But then we move on to going ahead and doing the log base 10 of the column. So all we have to do in this case is just log 10 of a2, hit enter. And then the great thing is all we have to do is go ahead and click and drag, and it'll go through and do the entire column. And a good check of this is just to go down data by data point real quick. So we have up here in the editor, log base 10 of a2. And then, whoops, there we go. We can reset that. So you can see it's a2, 3, 4, and so on. So with that check out of the way, let's quickly do the log of y. So this will be log 10 of b2 this time, and then push enter. And now we can click and drag, and that gets us all of the log base 10 of y. So now to get the errors in your log x and y, as you see in the workbook, this is just the fractional or relative error. So all we have to do is take our absolute error, which is in columns C and D, and divide them by the averages, which are in columns A and B. So for x, all we need to do is equal sign C2 over A2, just like that. That gets us our fractional or relative error. And then again, we can just click and drag, and this will do it for the entire column. And then similarly for y, it'll be D2 over B2, because everything's shifted over one column to the right. And then we can go ahead and click and drag. So now I'm going to go through the graphing techniques for just log x versus log y. When you go do the workbook, you're going to need to do both y versus x and log base y versus log base x. So that little stutter actually really brings out a good point of clarification, in that when you plot something in Excel, you want your x on the left, your y on the right, which is confusing because when we say we graph two things, we always have y versus x. So it's a little bit backwards, but typically when you're graphing with things, always have your y on the left side of the verses, your x on the right side of the verses. But in Excel, to graph things, you want to make sure x is on the left, y is on the right. So with that, we can go ahead and plot the logarithms. So all you do is you click and drag, you select all of the data you'd like to plot, just like that. And now we go to Insert up here in the menus where you see my cursor flying around a little bit. We click Insert, and now it's great because scatter plots, which is what you're going to end up making, is one of the most common tables out there. So what's great is then we can just click Recommended Charts, and lucky for us, it's the first one that pops up. So there we go. So now we have a graph of the logarithms of both x and y. So the log of y versus the log of x. So now, like I said earlier, we need to know what the power law is. So what n power are we dealing with? So we get that by doing a linear regression line and stating its slope, essentially. So how we get that linear regression line, we do add chart element, and now we go here to trend line, and now we do linear. And there you go. It immediately gives the linear regression and plots it right there for you. But we need to know what the slope of this line is. So to do that, to find that out, we double click it, and then this menu will pop up. Make sure you're on the 3-bar graph menu here, and then display equation on chart, just like that. So as you can see here, the slope of the line is about -0.8. So what that means is y equals x to the -0.8. And to give you an idea of what that looks like with powers, remember we have a negative exponent that's the same as 1 over that exponent. So this is 1 over about 4/5. And then remember, when we have a 4/5 exponent, that's like raising it to the 4th power and taking the 5th root. So that's what's going on between these random x and y points. So now that we know what the relationship between x and y looks like, we can go ahead and add in their error. So to do that, make sure you're clicked on the chart, in which we are, and you're going to go into the same menu we added the regression line. So make sure you're in chart design, so not home, not insert, not any of these other ones, but chart design. And again, this is the same for the regression line. We're going to again click add chart element, but instead of trend line, this time we're going to add error bars. And we're going to go to more error bars options because we're not doing standard error or percentage or standard deviation or anything like that. So we go ahead and click it, and to start out, as you'll see, we get big scary errors, but luckily we're going to go ahead and fix these. What you want to make sure of is that you're getting the right error onto the right data point. So its default is to start with a vertical error bar. So this is going to be your y value, your error in y. So let's go ahead and take a look at that. As we can see, we have, if I move over a little bit, log x and log y error. So to get this I column, as you can see, these values onto the plot itself as error, we want to go ahead and make sure we're on this menu again, this 3-bar menu. Under error amount, we want to move away from fixed and go to custom. So you click custom and then specify value and just delete whatever's here. And we're just going to do the same click and drag technique. So we're just going to go here. This is our positive error, and it'll be the exact same thing for our negative error. Because in this class, our errors are symmetric. That's why we have the plus and the minus. So the plus represents the bar to the right or to the top, and the minus represents the bar to the left or to the bottom. So it's going to be the exact same thing. Just click and drag. So once you have that, just click OK. And you'll see our errors got really small, which is good. This is about what we're ideally shooting for. So in this example, we don't have much error, which is very nice, but probably won't be the case in your lab, but you never know. So that's why it's really important to make sure you're using the right column for your error. But now the last thing we have to do is just click on the horizontal error bars, just like that. As you can see now, it says horizontal, so you're making sure you're on the right error bars. And again, it'll be the exact same process, well, almost the exact same process. You'll move error amount from fixed value to custom, and then you're going to specify values. But now, instead, of course, of using the Y column, instead of a column I, we're going to use column H. So again, just click and drag. There you go. Delete the second one, and again, just click and drag. And then you'll hit OK. And there you go. See, our error is resolved really nicely, and it will get something that looks like this. And if we were to see a graph like this, we can say that our measurements are pretty good. Our errors were not too bad at all. Another good indicator of that is because our regression line is passing through our error, so that's a very good sign. If there's a gap between your error and your regression line, then that's typically a sign of things not being accurate enough, or there was a lack of precision. Point is, there was definitely some error that crept in. So yeah, that is pretty much the basics of everything. All you'll have to do is you'll have to do this really 4 times, because you're going to do y versus x for the first activity, then their logs, and then repeat everything for the second activity. So you're going to do everything I showed you really 4 times to get 4 separate charts. And then yeah, before I go, just make sure that you change the title, again, by just clicking on the title and clicking on the axes, and you can go ahead and mess around with different formatting things, whatever looks good to you. Just as long as it's clear and I can clearly read your graph and can tell what's going on. But yeah, so be sure to give everything a title, label the axes, don't forget the units in your axes, you know, whether it be elephants, gumballs, clowns, whatever wacky thing you can think of. Just make sure you always specify your units. So, thank you so much for watching this tutorial. I hope it's helpful, and hopefully you'll be able to get everything you need for the third workbook. Take care, and bye for now.